Hello and welcome to another tutorial. So this time around we're going to be taking a look at making interactable screens, and this is something where I've looked at different sort of portions of this but haven't sort of looked at everything as a holistic thing. So what we're going to be creating is something where you have a UI that sits in world space. Now normally a UI that sits in world space, you're not able to do a lot of visual effects or things like that over it. We're going to be creating a UI that sits in world space, but then we're going to be projecting that essentially onto a screen, into an actual mesh, so that then that mesh can take on lighting in the world. We could do other sort of effects to it. Also makes it easy to apply post-processing just to that particular UI if we wanted. So we're going to look at the full sort of processes for setting that up, and then being able to have it that screen we can actually relay input, any clicks on it, to the actual UI. So there's a few bits and pieces we're going to be setting up, but that's sort of the main focus there of what we're creating. So what I'm going to do is I'm just going to create a folder here. Now this folder is going to be for dynamic screens. So there's going to be a few different things that I need for this. So I'm going to create a couple of assets first. So what I'm going to do is, one of the things that I want to have is a render texture. So the way it will work is we create our UI in world space. Then that UI that sits in world space, what we will do is give it its own custom camera that's capturing it. And we capture that into something called a render texture. And then that render texture, we can apply that onto a particular screen via using a material. So that's sort of the processes we need to go through for this. So what I'm going to do is, and I'm going to call this RT UI stage 1. So RT for render texture. And we're going to have essentially a UI stage is what we're talking about. Now, main settings that I want to adjust with this is the size. So I want to change that to the size that I'm sort of designing the UI for. So in this case, 1920 by 1080 is the size that I'm going for. I'm also going to create a material. So let's set up a material. So this is going to be Matte UI Stage 1. And all I'm going to do is bring that render texture in as our albedo texture. So okay, that's good. That's some of the essential bits we need there for this. So what I then want to do is, if we go over to layers here, I actually need to set up a new layer. So how I would do this is, so the layers here, so specifically layers, not the sorting layers. Layers are very useful for when you want to control what things get rendered by a particular camera. So what I would do is, for each one of these, I would create its own separate layer. So we create a UI stage 1 layer. And then our main camera here, I want to go and this culling mask for the main camera, I untick UI stage 1. Now I'm going to create my UI stage. So a couple of aspects of what I'm going to do for this. First thing is I'm going to create just a UI with a panel. And I'm going to create an empty game object that's going to be UI stage 1. I've made sure that's positioned at all zeros for now, and I'm going to drag that canvas under it. Now we can see at the moment that canvas is there taking up the full size of the screen. That's fine, because what I'm going to do is, selecting that canvas, I'm going to change the render mode from screen space to world space. I need to adjust my X and Y positions to all zeros. And the width, I set this to that same resolution I used for the render texture. Now, scale-wise, at the moment, I want to, this is going to be gigantic. At the moment, this would be almost 2 kilometers by 1 kilometer. So we're going to shrink that down. We don't want to go too far, but I think probably 0.01 is enough. Then that's okay that it's sort of taking up a fair chunk of the screen at the moment. That's not going to be an issue. So a couple of things I want to do with this that are really important. So I've got my canvas here. I've set the render mode. What I'm going to do is the graphics raycaster here, I'm going to turn it off. I don't want to remove it. I just want to turn it off because this UI, it's going to exist in the world, but we're never actually going to see it directly. We're only going to see it through that render texture. So by turning off the graphics raycaster, it means that if we accidentally clicked in the world where this UI actually is, it won't get registered. We can only pick up interactions through the screen. So that's why I'm turning it off. The reason I'm not removing it is because I actually still want to make use of it. It's actually still really handy for wrangling the input. So a couple of other things I want to sort of set up in here. So one thing I'm going to do is this background panel. I'm going to change the color of that. Let's go for sort of a darkish blue like that. So I don't want it to be transparent in this case. You could still have it be transparent, but this sort of works for the colors I'm after with this. I just want to create a little button that's going to be in the center. We'll let it import the Text Mesh Pro Essentials. So just got a button sitting there. That's good. I also just want to, because it's a good stress test for it, we're going to create a scroll view. So scroll views are always a good stress test for making sure that input is working, just because there are a fair bit of logic that sort of has to happen with them to make them work. So very good stress test for that. Now I want to have some content in there, obviously, to make sure that it's going to be working properly. So what I'm going to do is I'm going to create a Text Mesh Pro in there. And all I'm going to do is just put a bunch of numbers in there for now. Reason being that I really want to just have a big chunk of text that's going to take up more space than I actually have. That's sort of the big thing with this, is I want it to be one that's taking up a lot more space than I have. That should be more than enough. Now, even 30. Cool. So that's good. I've got my text there. That's set up in this. What I want to then do is on this, I am going to add in a content size fitter and change the vertical fit to preferred size. So we can see that's expanding to take up the full space. We will also adjust the anchoring for this so that it's taking up everything like that. Might give it a little bit of padding. So that's good. Then on the content one, what we do is we add in a vertical layout group. We tell it to control the width and height. And we're going to add another content size fitter and change the vertical fit to preferred size. So that's good. we've got things looking about right there now, which is good. So everything should be positioned well. Then what I want to do is I can just initially test this, make sure I can scroll the UI. So at the moment that UI is not interactable because I turned off the graphics raycaster. But if I turn it back on, I should see that I can scroll this. I've got a button that I can click on, so that's good. Now we're going to change this so that it's actually using our render texture and everything. So what we do for that is we've got our canvas, then we set up a capture camera. So we have our capture camera. Now, this will automatically have an audio listener in it, which if we leave that there, we'll end up getting errors when we play because there'll be multiple audio listeners, which we don't want. So we remove that. We change the clear flags, and generally for something like this, I would use solid color and a full black. The culling mask, we go initially nothing, and then we just select UI stage 1. And what I do is I link up my render texture. So now it's going to draw to that render texture. So that's the capture camera. What I also do is in UI stage 1 here, I change the layer of this and all of the children. So that disappears, which is what should happen. That's what we actually want to have happen. The other thing I can do here is our canvas. We link up our capture camera because that's actually the camera that's looking at it. Now what I can do is I'm going to create a 3D object and we'll create just a quad. Going to change the scale of this to match that of the UI. That looks pretty good. And then we will just bring that closer. There's probably good. Yeah. And I'm going to connect up that material. So at the moment, we can't see anything, and that's okay. I'm going to move my game view down here so we can see when it does appear. So if we look at our capture camera, where it's placed and everything, so it's sitting there, what I want to do is change the projection to orthographic. And then I'm going to bring the camera back just a bit. Now, it's not pulling in all of the screen. We can actually see that if I make the game view larger again, there's areas being clipped off here. So what you'll generally need to do is adjust the size of this. And there will be a spot where you will have a little bit of a border. You can definitely get it to a point where there is no border. Depends upon stylistically what you're going for. I usually like there being just this sort of thin little bit of a border. So, okay, we've got our stage and all of this going. Now, if I run this, what I will find is nothing happens. If I select the event system, it's never over any of the UI, so I don't actually have any ability to interact with this. So what I want to do is I want to actually make it so that that interaction is able to actually happen. So what I'm going to do is, and I'm going to create the script here. So this script, actually, yeah, now I can go into here. So I'm going to add a new script onto the UI stage. So what this script is going to be is this is the essentially the thing that will receive, that will relay the UI inputs to actually make the UI function. So this is going to be call this our dynamic UI stage. At that, and we'll move that script in a moment. What I'm going to do is this is going to be screen stage 1. This is going to get a script where what this script is going to be is our dynamic UI display screen. So we add that. Now, one important thing with this is I added this onto a mesh or onto a quad. So for this to function, it has to be on something with a mesh collider. It will not work if it only has a box collider or anything else. It must specifically be a mesh collider. Now, it could be a portion of a mesh. So this could be something that sits within, an actual 3D model that you have for a screen. But then you just need to ensure that you have proper mapping of UV coordinates and everything for that section in the middle. Or you could have this as a separate mesh, and the housing is a separate mesh as well attached to it. But these are the two sort of pieces we need to actually make this work. So let's start off with our script that actually handles the input in terms of relaying it to the actual UI itself. So that's our dynamic UI stage. So it has a few things that we need to do with this. So a couple of things it's going to actually have to do. Now, one of the things with this is I want to make it properly support both input systems. So you'll see some specific things I do to enable that. So a couple of things that I'm going to need. I need access to the rect transform for the canvas. So I need the canvas transform. I'm also going to need that graphics raycaster. So that's my raycaster. Now, because I'm supporting things like that scroll rect and everything, that means I need to also handle dragging support. So to facilitate that, I'm going to have a list of game objects, and these are our drag targets. So that's good. So, okay, start an update. Nothing we actually need to do in those, so I'm going to remove those for the moment. What I want to have is I want to have an interface for basically receiving cursor input. So our screens are going to relay input to this. So we're going to have on cursor input. Now what this gives us is a normalized position. And by normalized position, what I mean is that the one corner of the screen will be 0, 0, and then the far corner of the screen will be 1, 1. So we can directly map from that normalized position to a pixel coordinate. And the reason we do that is because the input we get from when we click on that screen, what we're able to get out of that collision hit is actually a UV coordinate. So that's going to be from the 0 to 1. And then the screen stuff, all of that UI logic for working with it actually works via the pixel coordinates. So first thing we need to do is we need to actually get the mouse position, or get the input position in the actual canvas space. So vector3 input position. So this is a new vector3, and what we do is the x coordinate is our canvas transform, our size delta dot x multiplied by the normalized position dot x. Then we have a very similar thing with y, and the z component is just 0. So, okay, that gives us our position in a canvas space. So that works. What we then want to do is we need to actually construct a pointer event. So we have a pointer event data, and this is our input event. So that is actually, this is our pointer event, we call it. So that's a new pointer event data, and we need to get our current event system. So with this, we don't have multiple event systems, we do just have the one. So the pointer event that we're sort of putting together here, what this actually contains is all of the information that the UI needs to interpret, to understand, to process this of the event of what's happened. So an event could be just moving the cursor, an event could be clicking, an event could be, and with a click, there's the press and the release, so there's multiple aspects to it. So we're kind of building all of this up so that then we can inject that into the UI logic itself. So the next thing we need to do is we need to determine what things we actually might have hit in the UI, because we only want to send events to the things that we've actually hit. And so this is why we kept the raycaster around, because we get back raycast result, and that's our new list. And what we do is our raycaster, we tell it, okay, do a raycast. Here is the pointer event, and it will give us back the results. So that's good. Now, with this, there's going to be a bunch of things that we do, even if we don't actually get results back. So one of the things we need to determine first also is there anything special in terms of, okay, has the mouse gone down? Has it gone up? Stuff like that. Now, I want this to work for both the legacy input system and the new input system without any user intervention. So this is where I can use preprocessors for this. So there is one already set up, enable legacy input manager. So do an else and an end if. Just my usual checks that I would do here. So a couple of things that I want to be retrieving from this. So F, we've got the mouse down. So what we're looking for is get mouse button down. Now we do just check the primary button. Actually, we might go for mouse down this frame. We'll also have a mouse up this frame. Unsurprisingly, that's a get mouse button up. We also, because there's different bits of info, there's did the mouse button go down this frame? Did it go up? And is it currently down? So what we do with that is we just do a get mouse button. So that's good. That's the version that will work for the legacy side. Now for the new input system, we can still get these exact same ones. It just is going to look a little bit more involved. Now because I want to avoid risking typos, I'm going to just directly transfer from one I had put together beforehand. So this is a way of directly polling the new input system. So that's good. We're able to check the particular status of those. So we've got that information. Now we can start doing things with this. So, okay, first thing we need to check is handle sort of drag events. So has the mouse gone up this frame? Has the mouse button? So what we would say is, okay, well, if mouse up this frame, then what we need to do is we need to clear dragging. So we loop through every target in our drag targets. And then what we do is we go, okay, well, execute events. We tell it to execute. We give it the target. We give it the pointer event. And we go execute events end drag handler. So that's what it's going to send. Now, generally the way the return values can be interpreted from this is if something is returned true, then we can just break. We don't actually need to do any further handling. And then because we've cleared all of the dragging, we just reset our drag targets. Now we actually process any hit results. So we process any hit results. So we're looping through result. And there's going to be sort of similar logic to what we're doing here. The idea is we are injecting that pointer event data. So for this, what I've found is that I often need to actually create a new pointer event data. So we have another pointer event data. And then we're going to call this, we call the one up here, we called it pointer event. Let's call it pointer event for result. We create that in the exact same way. So we give it our event system current. We set the position. So we've set the position. There's a couple of other things we want to actually set with this. So one of the things is the recurrent raycast, which we want to set that to result. We also want to, there is a pointer press raycast that we want to populate as well. So we populate both of those. So that's good. Now we check if the mouse button is down. Is the button down? So FB is mouse down. So that's, is it currently down? Then our pointer event for result button, we actually set that to pointer event data, input button left. Left is the primary one. So that's just a reason why we're doing that, is so that it knows which button is actually down. Then what I want to do is I want to check to see if we are interacting with a slider, because those here are going to be able to be scrolling. So our result.game object, I want to try, except in this case, I can't do a try get component for the parent. What I want to do is do a get component in parent of our slider. So that's going to be slider. Call that hit slider. So if we actually hit a slider, there's going to be specific logic we need to do. So retrieve a slider if hit. So, okay, do we potentially have new drag targets? So new drag targets. So if mouse is down this frame, then what I do is I do an execute event. We give it our, execute events, execute. We give it our result.gameObject. We give it our pointer event that we've constructed. And then the specific event that we are dealing with here is our begin drag handler. So if this returns true, then that means that whatever was hit has actually handled that. And so it is processing a drag. So we go and add that result.gameObject to our drag targets. Now, if we hit a slider, there is some additional logic that we need to do. So we do hit slider on initialize potential drag. We give it the pointer event data that we've constructed, and we check if the drag targets does not contain this game object, then we manually add it in. Get rid of that so it's following our coding conventions. And that can happen because what we're clicking on is part of the slider. It's not the actual slider game object itself, and we want to make sure that it's the slider game object that we've got information being passed into there. So okay, potentially got new drag targets that we're handling there. If the mouse did not go down this frame, we need to see if we need to update them. So we need to look for if the drag targets contains this current game object. Targets. So we're looking to see if we need to update anything. If we are, then what we do is we set dragging in that pointer event data to true. We do an execute events, and very familiar pattern by this point. Result.gameObject, pointer event data that we've constructed, and in this case, the event is the drag handler. So we don't check to see if this succeeded or not. There's nothing we're wanting to break out of with this. We're just wanting to properly handle that. But again, if we hit a slider, it actually has a slightly different bit of logic we need to do for that. So we tell it on drag and give it the data as well. So it was a little bit of trial and error figuring out the particular combination that sliders needed, which is a little less than great, but it ends up working. So that's good. We're nearly done with this. The other things we need to handle is, okay, mouse down this frame. Well, in that case, now in this one, we do our execute events, but we check the result because if it succeeds, we actually don't need to handle anything further. So game object, so again, very familiar by this point, our execute events, and that is our pointer down handler, I believe it is, yes. So if that's successful, we just do a break. So the way the UI logic generally works is when you execute an event, if something successfully executes it, then you don't need to process any of the other results that come back from the raycasting. Otherwise, we look for our mouse up this frame. Oh, that's right, it should be else if. That'll make it happier. So then we check, okay, cool. B did run. I'm going to just set it to false. And the reason I'm doing this is because we actually have two ones that we have to run. And as long as either of them is successful, then we consider this input successfully consumed. So, very familiar logic at this point. Pointer event for result. So in this case, we execute events. So the two ones that we want to execute in this case is we have a pointer up handler, which will send that. And then immediately after it, the one that I'll send is a pointer click handler. And then if we did run, then we can just break because we've consumed that input. So that looks good. Now with this, I can then link up a couple of things. So for one thing, I can link up the canvas and get the raycaster as well. So those are fully linked up. Just save all of this. Now I need to make this screen actually work, because at the moment this won't be enough to have it work. What I need to do is I need to implement this logic for our actual display screen. So that's the last part that we need to actually get set up with this. It's also a very simple part to it. So what it needs to do is a couple of things. One thing is it needs a layer mask. Because it needs to do a raycast to figure out where we hit on the screen. So by default, we're going to accept all layers, which is why we're doing ~0. It's going to select all of the bits. We have a maximum distance that we want to raycast up to. I'm going to just set to, let's go for 5 meters. And then we have a serialized field for a Unity event. And this is actually paired with that click handler function that we set up, or the cursor input one. So input is new. So that's good. Nothing needed in start. That's all good. Now update is where we actually have the main bit of logic. So we need to again be checking if we've got our legacy input system. The reason being is that there's a very slight difference that we need to do. It's literally one line that is different between the two. But what I do is for this one, I have my mouse position is input.mouse position. Now for the new input system one, it's a little different. I will just, again, copy and paste this in just in the interest of making sure I don't get it wrong. So that's good. Then the logic that we follow is pretty straightforward. We do our usual setup for creating a mouse ray. So we go camera, main, screen point to ray for that. So we construct our ray from the mouse position. So this is going to allow us to figure out where the cursor currently is. Now, depending upon what you're doing, if you had something where there isn't a cursor that you're freely able to move around, you might be using this as the center point of the screen. So this is specifically for if you have the mouse moving around, because I don't have the camera able to be turning in this. So that's something that you would vary if you wanted the camera to be able to move. Then we perform our raycast. So we have our raycast hit result, and we do our physics raycast we use our mouse ray. We have our hit result. We have our distance. We have our mask. And our query trigger interaction. We want it to just not ray trace against anything that's a trigger rather than a collider. So we ignore if it's not us. So if the hit result collider game object is not equal to us, then all we do is return. Otherwise, we do our onCursor input, invoke, and our hit result, and what we get is the texture coordinate, like that. So I need to raycast mask. We don't want to raycast against UI stage 1. In fact, with this, we only really want to be raycasting against the default. We just want to raycast against this screen that we're clicking on. Now, for the onCursor input, we bind that to our stage, and in particular, to that onCursor input function. So let's test this out. So, okay, can see the button is slightly changing. Might be a little bit difficult to see, so I'll rig up some test stuff to work with for that. But our scroll bar is working. It's picking up dragging. So let's make it that, firstly, we'll make that button, let's increase its size a bunch. That, and we'll increase the text size on it as well. Make it so it's very obvious that we're actually interacting with it. So what I'm going to do is I will create a C# script, and we'll just call this debug helpers. And what this debug helpers script is going to do, so I'm just going to put this on the button. I'm going to give this a public void display message. Supports getting a message taken in like that, and I'll just debug log it out. Because then what we can do is we can link our button to when we click to running that bit of logic. Debug helpers, and we have our display message button from UI stage 1. So that's good. Make sure things are saved. So click on that, we're seeing the output. Now, the cool thing with this, because with how we've set this up, is that screen stage, well, it's just a thing in the world, and it can get lighting and everything like that on it. So if I go and rotate it, we can see that we're getting lighting appearing on it. We could adjust the material as well to adjust the appearance of that. So our material here, we could be tinting the UI. All sorts of things like of that we can now do with this. And regardless of the angle, this will just work. Can get a little weird if you're trying to scroll with something on a weird angle, but that behavior works. That's the key thing with it. So that's good. So, okay, we've got one stage. I'm going to shrink this down a little bit. So we're going to divide that by 2. Actually, if I set this to uniform scaling, that'll be even better, because then everything scales down. So that's good. And the reason I'm doing this is because I'm going to position this one at -1. I'm going to show for creating a second screen, stage 2. That's going to be at +1. Now what I do is my UI stage 1 here, I duplicate that. So that's UI stage 2 now. I'm going to change its appearance. So that panel, let's make it a darkish gray background for it. So both screens are looking the same at the moment. That's fine. The reason being is I need to duplicate my render texture firstly. I do that and update the camera of stage 2. So, okay, we've got stage 1 and stage 2. That looks good. Let's update my material here. So stage 2. So it uses the different one. So, okay, the different screens here, we make sure they are using the correct materials. So that one needs to then use material stage 2. So, okay, we've got our 2 different ones there. What we also need to do though is we need to create a new layer. We need UI stage 2. Now we go and make sure that things like our main camera, still not rendering that, which is good. UI stage 1 camera, we make sure it's only seeing that, which is good. Stage 2, we change the layer of everything. So we can see that's now reset. We change the camera here. We get rid of stage 1. So that's good. So everything is linking now to the proper particular ones. The only thing we have to change is which on-cursor input gets linked. And I'm going to just change the message the button displays. So let's run this, and what I should find is, okay, click this, we got stage 1. Now this one, it's not picking up anything at the moment. And the reason we will find for that is we need to link up the on-cursor input. We also, our raycast mask is all good. The no function, and then I'll try to link that back. Okay, that's happier now. Unity just got a bit confused with the duplication. So stage 1 is working, and stage 2 is working. So we could repeat this process for as many screens as we wanted. We could have, for stage 2, could actually have stage 2A and stage 2B. We could have multiple screens that interact with the same one. So let's put this one at 1.5 and this one at 0.5 and then run that. So we can see with that, you could have multiple screens, display screens also linked to the same UI. So it gives us a really, really powerful setup for being able to have these systems actually work. And if I change this to a solid color, that's going to make that stand out a little bit nicer as well. But we've got our multiple screens, and those screens connect to different UIs. They are something that can take on lighting in the world. They can be, given post-processing effects could be applied to those different stages. So there's a lot of things that we could then do with this in terms of customizing how they look. They're going through a material, so we could adjust the shader. We could set up our own custom shader that's applying particular effects or distortions to the screens. We can tint them. So it allows you to have a much more sort of dynamic, useful aspect there of 2 screens in the world, and is able to be done with pretty reasonable cost. The main things that we sort of need to remember is just setting up our other layers and making sure that the things are all connected together. But with how this works, it'll work for the current input system and also the new input system. So we have something that's going to be working for both. So dive on in and experiment with this. See what kinds of things you can add to it, what kind of things you might want to create, cool little bits that you could be using this for in your games. Thanks, folks. Hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. It really helps out. It's really appreciated. If you've got any questions on the project, chuck those in a comment below. If you were looking for the code for the project, the code is available up on GitHub, and I've put a link to that in the description. You can use the code in any of your own projects, whether those are commercial or non-commercial ones, you're able to be freely using it. And if you're looking for other ways to support the channel, then I do have a Patreon as well, and there's a link to that in the description also. But until next time,